All right, so this is 11.7 day one notes. And the first thing we're going to do today is just continue with what we did on Friday. So if you were not here on Friday, you will need to get a blank sheet of computer paper. I had students draw in what they could from memory of the first quadrant, because remember, that's all that you need in order to be able to fill out the entire unit circle. Okay, and we are having our unit circle quiz this week. So I'm going to show you a little trick for the tangent values for quadrant 1. Last week we talked about how you can divide, okay? But the tangent is also going to follow a pattern. So we talked about how the tangent of an angle is equal to the y-coordinate divided by the x-coordinate. So what we're going to do is we are going to calculate the values for quadrant 1. Okay, so we're going to calculate the value for 0. So at 0, which is right here, your point is 1, 0. So I'm going to have you calculate the tangent. Then I want you to do that for pi over 6. So at pi over 6, your point is root 3 over 2, 1/2. Okay, I'm going to give you some time right now to calculate those. So you are doing the y divided by x. Okay, you're doing y divided by x. You're finding that tangent. Okay, so as we are setting that up, we are thinking to ourselves, what is 0 divided by 1? If 0 is in the numerator, it is going to be 0. Okay, and then here, this is x, this is y, so 1/2 divided by root 3 over 2, okay, is going to give us keep, change, flip. Okay, so then these would cancel. We can't leave this as 1 over root 3, so we're going to multiply. So we get root 3 over 3. Okay, thumbs up if you got those. All right, so after pi over 6, what's the next one we're going to do? Pi over 4 is right. Okay, after pi over 4, pi over 3. After pi over 3, pi over 2. And that is quadrant 1. Okay, so I want you to keep going. Okay, so you have these written on your paper, right? At pi over 4, your point is root 2 over 2, root 2 over 2. Okay, so you have your x and your y. I want you to find the tangent. So tangent is always your y over your x. Okay, if you're watching the video, I want you to take the time to do it right now. Okay, don't tune out. You're going to learn more if you're trying this on your own. Okay, and pi over 4 is my favorite one. It might be yours too because they're the same thing, right? Root 2 over 2 divided by itself is just what? 1. So anything divided by itself is 1. Okay, so you don't even have to do the keep, change, flip, right? We can use that property. All right, and then for pi over 3, you have 1/2 root 3 over 2. Okay, so when we set that up, okay, it's keep, change, flip. And if you want to do that right away, you are welcome to. And then when you simplify, you just get root 3. Okay, now pi over 2, your point is 0, 1. So you have your x and then your y. So when you do 1 divided by 0, what is our solution? Undefined. Okay, so the tangent does have a few places on the unit circle where it is undefined. So we're just going to draw a little quadrant 1 here, and we're going to write out what the tangent values are. Okay, so you can always calculate the tangent values. That's what we just did. You can always find them by doing y divided by x. But some people like to use this pattern because we can see that, oh, here at 0, the tangent is 0. At pi over 6, I have root 3 over 3. At pi over 4, I have 1. At pi over 3, I have root 3, and then at the top, it's undefined. Okay, so they really go in order from the least to the greatest. Okay, so the square root of 3, I know that that's bigger than 1, because what's the square root of 1? 1. What's the square root of 4? 2, right? Okay, so square root of 3 has to be somewhere between 1 and 2, so it's definitely bigger than 1. Okay, and then if you divide this by 3, that's obviously going to be smaller than this. Okay, and we know that this is smaller than 2. Okay, so then that means that has to be smaller than 1. So you can use some number sense there to say, oh yeah, this is going in order from least to greatest. So it's the root 3 divided by 3, then 1, and then root 3. If it's helpful, you can also put your radian values here, the pi over 6, the pi over 4, the pi over 3, and the pi over 2. Okay, so these are the tangent values. Okay, so when you submit your notes today, you will submit this paper as well. Okay, so if you were gone on Friday, okay, it's not due till tomorrow, so you do have some time to get that first quadrant written down. And then today we're going to learn about inverses of trig functions, which you probably noticed there's many things that we've done that are review from geometry. Well, you also did some inverses of trig functions in geometry. Okay, we're just going to extend them a little bit more because we're going to have the radian values as well. Okay, so the key concepts, you've evaluated the trig functions to find an angle or for a given angle, like you plugged in your angle, you found the side length, but you can also find the measure of angles given the value of a trig function using what is called its inverse trig relation. Okay, so the inverse trig relation. Okay, so in this function, in the inverse relation, theta, from what we did last week, was the input. In the inverse, theta is now the output. Okay, so in the function, theta is the input. It's what we plugged into the function. Now, theta is the output. So it's what we're going to get out when we plug something else in. Okay, so the reason why they call it a relation and not a function is because the input value can have more than one output, which means it's technically not a function. Okay, so the input value can have more than one output. And that means it's not a function. Okay, so that's why they call it a relation. What is the difference between an inverse and the original function? So in this case, the input and the output value switch. Remember we studied inverses earlier this year and we found out the input and the output switches. The same thing happens with these trig functions. So the input and the output values switch with an inverse and the original function. And we're going to see how that works with our unit circle here. So in example 1, it says find all possible values of, and then the way that this is written is the cosine, and then you have this little -1. It looks like an exponent. It's not. Okay, that is the inverse symbol. So this is the inverse cosine of √3/2. Okay, so what you're going to do is find the values between 0 and 2 pi radians for which the cosine of theta is equal to √3/2. Okay. So what we're going to do is we are going to look at our sheet that we have out. And remember with cosine, you have your x-coordinate. Okay, so where is the x-coordinate √3/2? So if I'm looking at my first quadrant, do you guys know one of the places? Yep, at 30 degrees, which in radians is? No? Pi/6. Yep. Okay, so at 30 degrees, it's the pi/6. So at pi/6, and I'm just writing down this point so visually you can look and see why this is the correct one. Okay, and then the other one you can find with all students take classes. So everything is positive in quadrant 1, sine is positive in quadrant 2, tangent in quadrant 3, cosines in quadrant 4. So if this is a positive value here, which it is, okay, then you know the other place where this is positive, the cosine is positive, is quadrant 4, and you just have to find the reflection of that point. Okay, so you're finding the angles that are coterminal with those values in the next step. Do you guys know what we call this? This point here, what this one is? So if this is pi/6, do you guys know what this one's going to be? It's 11 pi/6. Okay, and if you need to use your full unit circle to kind of help you with that as you first get going, that is fine. Okay, so if you are looking at your unit circle, you're like trying to find all the places where you have a positive √3/2. You can see here it's positive, here it's a negative. Okay, in quadrant 3 it'll be negative, in quadrant 4 it'll be positive again. Okay, so you have yours completely filled out and you are able to see that. So this is positive √3/2, negative 1/2. Okay, and then it's because of your x-coordinates. Okay, so this is part of your answer, pi/6, 11 pi/6. Now, in the directions, it says find all possible values here. Anytime they say all, you have to write an equation. Okay, and we are always going to be using radians for this. Okay, so to find the all possible solutions, we're going to find the angles that are coterminal. Okay, so that means they have to be coterminal with pi/6 and 11 pi/6. All it is just rotations. Okay, so anytime you have to find all of them, if you do a rotation, that is just plus 2 pi times n, where n is an integer. So we write it as an equation plus 2 pi n, where n is an integer, and n is the number of rotations and the direction. So all we do is we put plus 2 pi n plus 2 pi n. Okay, so we have plus 2 pi n plus 2 pi n. So if I wanted to rotate one time around the circle, if I added 2 pi, I would be right back here. Okay, if I wanted to go in the negative direction, I would plug in -1 for n. Again, I would be back here. So the plus 2 pi n just means you're rotating 2 pi, okay, either once, twice, however many times you want, and then you can go in the positive direction or the negative direction. All right, for part B, we're doing the tangent inverse of -√3. Okay, so when I do this, I like to make visuals for how I'm thinking about it. Okay, you don't necessarily have to write the visual, but for some of you, if you're struggling with figuring out where this is on the circle, a visual can be very helpful. So I just draw a circle and I think to myself, okay, where is the tangent going to be √3 in quadrant 1? So we just wrote out the tangent values today. So I can see that this is √3 at pi/3. Okay, so in my mind, I'm thinking, all right, this is where the tangent is √3. Remember that everything is a reflection. Okay, so this is at pi/3, I'm at √3. If I want it to be negative, I think of all students take classes. So in what two quadrants is the tangent going to be negative? In quadrant 2 and quadrant 4. So I just have to find the reflection points. So I just reflect here. I have to find what this is in terms of radians. Can you guys tell me what this is in terms of radians? Yeah, 2 pi/3. Because see how this is 1 pi/3? So this is going to be 2 pi/3. And then remember this relationship here? This is where it's going to be because it's a reflection. It is going to be straight across the circle from this. So what would that be in radians? Mm-hmm. 5 pi/3. Right? Because this is 2 pi. 2 pi minus pi/3. You could think of it that way. Okay, so tangent is negative in quadrants 2 and 4. So you know you have to find those values in 2 and 4. Okay? And again, if you need to lean on your unit circle while you're first getting used to this, that is fine. Okay, so this one, we're just going to write as 2 pi/3 plus 2 pi n, and then 5 pi/3 plus 2 pi n. Okay, so this is where you have the negative, this is where you have the negative. Now, I know I didn't necessarily verify that here. You can absolutely do that with your values. So if you go to 2 pi/3, you have -1/2 √3/2. So with the tangent, remember how you can divide them? Okay, so you could do √3/2. Okay, y divided by x, and then you could verify that. Okay, so root 3 over 2 times negative 2, those would cancel. You'd get negative root 3. Okay, eventually you're just going to recognize the patterns. Okay, but do what you need to do in order for that to click. And it's okay if it takes you some practice. Okay, it should. This is new stuff. All right, let's talk about some restricted domains. So with a restricted domain, your textbook is going to indicate these with a capital letter. Okay, so see how this is the capital sign, capital cosine, capital tangent. Okay, that means the trig functions have a restricted domain. So you can only plug in certain values. These values are sometimes called the principal values. Okay, and they each have a special restriction. There is a reason why they are restricted the way that they are, but we aren't going to explore that for another week. Okay, so just bear with me for some of these, and know that we're going to keep revealing things every week, hopefully at a manageable pace for us. Okay, so we're going to use the lowercase. So this is the lowercase s. Okay, and this is for negative pi over 2 to pi over 2. That's the restricted domain. Okay, sine and tangent have the same one. So for the tangent, it's the same thing as the lowercase tangent for negative pi over 2 to pi over 2. Okay, so they are the same, and then cosine is a little different. For cosine, it's restricted from 0 to pi. And actually, that's fine. Okay, so for the sine and the tangent, negative pi over 2 to pi over 2. For the cosine is 0 to pi, okay? So I'm going to tell you why they are the way they are, but we're not really going to fully realize the actualization until we look at the graphs of these functions. But these are based on where the functions are 1 to 1. Because remember earlier we said, oh, these are called relations because you're going to have multiple outputs and for an input, and that means it's not a function. So we do these restrictions so that it can be a function. Okay, so let's do a visual. Okay, if I'm going from negative pi over 2 to pi over 2, I'm going to draw my little unit circle here. Okay, pi over 2 is at the top, negative pi over 2 is at the bottom, right? So if I go from negative pi over 2 to pi over 2, what quadrants am I in? From negative pi over 2 to pi over 2, I'm in what quadrants?
4 and 1.
4 and 1. All right, let's do those in. Okay, so this would be quadrant 1 and quadrant 4. Okay, and we can do the same thing here. But the visual does help with memory. So in case some of you are like, why does she keep saying the same things over and over again and we're drawing pictures? It's to help with your memory. Okay, so it's to help it stick so you can have a picture in your mind. Okay, so this is for sine and tangent. Why does this lady use so many colors? It's all for your memory. Okay, so when you do the cosine, put that in a different color. So that goes from 0 to pi. So 0 to pi is going to be what quadrants? So if I start at 0 and go to pi, that encompasses what quadrants? 1 and 2. Okay, so quadrants 1 and 2. Okay, so when we find these restricted domains, okay, we're only going to find the sine in this interval, the cosine from 0 to pi, the tangent from negative pi over 2 to pi over 2. Okay, and I did put a picture on here that does sum up what we just talked about. On this one, I just want to emphasize a few things. So the inverse sine function, okay, is written like this. So you see that -1. This is also called the arcsine, A-R-C, the arcsine. And spoiler alert, it's the arc cosine as well. And the arc tangent. All right, and then for the inverse cosine, we can see that has its own notation. And the arc tangent, the inverse tangent, has its own notation. And then we go on to the domain and the range. So when we think of domain, we're thinking of input. What can you plug into a function? Now, the domain for the sine and the cosine, let's pay special attention to those. You can plug in -1 to 1 and -1 to 1. Okay, so here, this is between -1 and 1. This is between -1 and 1. Okay, but what is our domain for the tangent? What's this? -infinity to infinity. All real numbers. Okay, that means there's no restrictions. You can plug in anything. Okay, and then your output, these are going to relate to your solutions. So we just talked about these in terms of the radians, -pi/2 to pi/2, which is -90 to 90. And we know that that holds true for the sine and the tangent. So our outputs would be in quadrant 1 and quadrant 4. Okay, and then we know that the cosine is 0 to pi, 0 to 180 degrees, which means that you are in quadrant 1 and quadrant 2. Okay, and that's for the outputs. So when we go to evaluate the trig functions, we're going to answer in both radians and degrees. Okay, so when we are looking at these, you will see the capital letter. So this is the cosine inverse. If there's a negative, sometimes there are the parentheses there. Okay, and I'm going to go over what you want to ask yourself. Okay, so when you see this, because of the restrictions, you're asking yourself, where in quadrant 1 or 2 is the x value -√3/2? Okay, so where in quadrant 1 or 2 is the x value? Negative root 3 over 2. Okay, so just based on what we know about all students take classes, everything's positive in quadrant 1, so it has to be in quadrant 2 where the cosine is negative. Okay, it has to be in quadrant 2. Okay, so if it's in quadrant 2, I always think of, all right, in quadrant 1, where is the cosine root 3 over 2? Because I can use this to help me with that. So at pi over 6, okay, I know that I have the root 3 over 2. So I just have to find the reflection point in quadrant 2. Okay, so if here it is root 3 over 2, the reflection is where it's a negative root 3 over 2. Okay, so do you guys think you can find that in radians or degrees? Okay, so some of you are going to pick up on this right away. Others of you, it's just going to take more time to get used to it. That's okay. And if you're already done with A, if you want to go to part B, you can. Well, part B might be kind of hard. Maybe wait for me for part B, but you might be able to do part C if you're ahead of me a little bit. Okay, so you're writing out what that value is in degrees and in radians. Okay, now when you get your answer, be sure it is in the range. Okay, so for cosine, has to be between 0 and 180. You okay?
Yeah.
Okay, so we know, I'll go over this again. So we know that this is where it is in quadrant 1 because we drew it out and we could see root 3 over 2. You guys with me on that? But are you really?
I am, yeah.
Okay. And then everything else is just a reflection. So if I reflect that point in quadrant 2, because cosine's in 1 or 2, okay, then all I have to do is find what this is in radians and degrees. So you can think of your reference angles, because what is this reference angle here? 30 degrees, pi over 6. Okay, so then if this is 30 degrees back from that, what will we call this? 5 pi over 6. And then how many degrees is that?
150.
150 degrees. Yeah. Okay, so your answer for this is 5 pi over 6, 150 degrees. Okay, and I always think of like, oh, pi is 180. Okay, so you can think of it as pi minus pi over 6 to get 5 pi over 6. You can do that. You don't have to write this down. I'm just trying to help you make sense of where these are coming from. These are the calculations that you'll be doing.
I don't get the point.
The
No, like why do we want to know?
Oh, the cosine. So these are going to relate to different graphs. So as we start to build this, more of it will come together. But yeah, the unit circle is a pretty cool thing in terms of your signs. So the sine and cosine in particular, their graphs are waves, and they can model a lot of different situations. So we're going to be using some of these to help us model those situations. Oh, because for the cosine, it has to be in quadrant 1 or quadrant 2. Okay, so that's a good point. So in your on your unit circle, there are going to be two places where it's a negative root 3 over 2. One of them is 5 pi over 6. The other one is 11 pi over 6. Because we're using the restricted domain, we have to use the one that is in quadrant 1 or quadrant 2 based on the definition. Okay. And then for part B, you have the sine inverse of 3 over 2. So what you would be asking yourself is where in quadrant 1 or 4 is the y coordinate 3 over 2. Now we have y coordinates that are root 3 over 2, but not 3 over 2. Okay, so the answer to this is a little bit tricky. It's nowhere. Okay, so what we have to do is we have to check the domain for some of these. So when you are looking at this chart, you can see the domain has to be between -1 and 1. 3 over 2 is 1.5. So because of that, our answer for this is going to be undefined. Okay, so we're going to write out why that is. So it's since 3 over 2 is greater than 1, it's not in the domain. Okay, thus our solution is undefined. Okay, and then if you get really stuck, you could also do the inverse in your calculator if it's not in the unit circle, and it will give you an error. So if you do the sine inverse, they don't have the capital sign, but if you try them in your calculator, it would give you an error. All right, now for this one, it's the arctangent. So this is just another way to write the tangent inverse. So this is the same thing as the tangent inverse of root 3 over 3. Guys, I need you to focus for this stuff. This isn't easy. Okay, so the tangent inverse of root 3 over 3, okay, is where in quadrant 1 or quadrant 4 is the tangent root 3 over 3. Okay, so I'm always writing out what you should be thinking. If it's tangent, it's 1 or 4. Okay, so you're not going to worry about if it's in 2 or 3 because this is what your output has to be. Okay, so first, is it going to be in quadrant 1 or is it going to be in quadrant 4? Why? Yep, so if it's positive, it has to be in quadrant 1. Okay, so the tangent is positive. Okay, some of you might know this right away just based on what we did today. Or some of you are already thinking about what your answer is going to be. Because didn't we find where the tangent was root 3 over 3? Yeah, where is it?
30 degrees.
Yeah, which is, yeah, so it's root 3 over 3 at pi over 6, which is 30 degrees. Okay, so that's your answer. It's just equal to pi over 6, 30 degrees. Okay, so all you're doing is finding where in radians and degrees is the tangent root 3 over 3. Okay, so now for D, I want you to do this. The tangent inverse of negative root 3 over 3. So the part I always ask you to think about right away, you should be saying, oh, this one was quadrant 1 because it's positive. So now we know it's quadrant 4 because that's where it's a negative. So, okay, if I know that it's positive here at pi over 6, that's where it's positive root 3 over 3 in quadrant 1, how are we finding where that is in quadrant 4? What are we using to find that? Yeah, the reflection, okay? So I'm just drawing out the reflection here, okay? Now this one, tell me what this point is. Because a lot of you know. Okay, so it's 11 pi over 6. Now, we can't write it as 11 pi over 6. Why, Miss Whipple, why? Because, let's think of the range, okay? So remember that our range has to be between what and what? Negative, the range.
Oh.
So the range has to be negative pi over 2 and pi over 2, okay? And just so you know, the reason why it's less than here is because what happens when it's equal to? What did we explore today? When it was at pi over 2, what was the tangent? Undefined. That's why they don't put the equal to, okay? Not a huge deal. Okay, so that means you have to be in between these. This is a negative half of a pi, and this is positive half of a pi. 11 pi over 6, that's bigger than that. But remember, we can write angles in 2 different ways. What's another way I could write this angle? I could write the positive angle as 11 pi over 6, or I can write the negative angle as negative pi over 6. So remember how we wrote the negative angles? Those coterminal angles? So it is going to be the negative one, okay? So 11 pi over 6 is not in the range. So we use the negative coterminal angle. So because 11 pi over 6 is not in the range, we use the negative coterminal angle. So you could just subtract this from 2 pi. Eventually, you're going to get to a place where it's just easier for you to recognize, oh, if this is pi over 6, if I go the same distance, this is just negative pi over 6. And what would that be in degrees?
Negative 30.
Negative 30. So it's just negative pi over 6, right? Negative 30 degrees. Okay? So make sure you guys have written down the notes that I have written down. I really do think it will help make some of these things click for you. And then your worksheet will be due tomorrow, and I'll pass that out now.